Okay, so in this first example, what we're going to do is rather than just differentiate with respect to x, we're going to differentiate both sides of the equation with respect to x. So my plan here is to differentiate both with respect to x. Okay, so whatever I do to one side, I'm going to do to the other. So what I'm going to have here is x squared plus y squared, and I'm going to differentiate that with respect to x, and I'm going to differentiate 16 with respect to x. Okay, well, I'm going to start on the easy side here because differentiating a constant is always just 0. And then when I differentiate this with respect to x, that's something we've done before, that's just 2x. And when I differentiate this with respect to x, then I get something different. So I want you to think about the chain rule a little bit. This is 2y to the power 1, and then I need you to differentiate that y with respect to x. So that's just dy dx. Okay? The derivative of y with respect to x is dy by dx. Okay? And now if my goal is to determine dy by dx, you can see that there. And so I'm going to isolate that as if I would any other algebraic piece, and then I will have an expression for dy by dx. So 2y dy by dx is going to be negative 2x. Divide both sides by 2, and divide both sides by y, and I have dy by dx is equal to negative x over y. Okay, and as usual, I've used up all my room there, but let me just write it again. Dy by dx equals negative x over y. Okay, let's try the next one. Alright, so I'm going to do the same thing. I'm going to differentiate both sides with respect to x, and on this side we have y to the power 4 plus 3y minus 4x cubed, and on the other side I have 5x plus 1. Okay, on this side when I do the first one, it's a y is the variable, so I'm going to apply my chain rule, and this is going to be 4y to the power 3, and then the derivative of y with respect to x is dy by dx plus 3y to the power 0 times dy by dx. And that'll cancel later, or that's just 1. We'll eliminate that in a second. And then the next one will be negative 12 x to the power 2, and dx by dx is just 1, so that's done. And then on the other side we have 5. Okay, so 4y cubed dy by dx plus 3 dy by dx equals 5 plus 12x squared. Alright, so now I've got a common factor there of dy by dx. So let's factor that out. Dy by dx times 4y cubed plus 3 equals 5 plus 12x squared. And then isolate dy by dx, and we have dy by dx equals 5 plus 12x squared, all divided by 4y cubed plus 3. Okay. And I don't see any common factor there that can simplify, so I will call that my derivative with respect to x. Okay, this is called implicit differentiation because we're taking the derivative for each part. There's more than one way to do that.